Okay, in this video we're going to see how to find the area between functions. So if there's two functions, f of x and g of x, and if they intersect at points when x is equal to a and x is equal to b, and if f of x happens to always be greater than or equal to g of x for every x between a and b, then the area of the shaded region between the points of intersection is given by the integral with the bounds of integration of a to b of f of x minus g of x. Now, f of x is always greater than g of x. So we're going to label f of x as our upper function, and g of x could be our lower function. Now, to see this on a graph, we see that this is two arbitrary functions, but again, f of x is considered our upper function, and g of x is going to be our lower function. And we're going to be finding the area between these functions between the bounds of integration of a and b. So as an example, we'll try to find the area bounded by the x-axis and this quadratic, x squared minus 2x. So to do that, what we're going to first do is figure out where do the x-axis and the function intersect. What are the bounds of integration? We're going to have to solve for those. The x-axis intersections are going to be the zeros of the quadratic. So we need to find the x-intercepts. So to solve, back from Algebra 2, we're going to factor an x out. So it's x times x minus 2. And we're trying to find when is this equal to the x-axis. So in other words, when is this function equal to 0? Well, that's going to happen when x equals 0 or when x equals 2. These are our bounds of integration. So now I'm going to write the integral from 0 to 2, and now I have to identify the upper function. So in this case, the x-axis, our parabola opens up. So I know I have a parabola that opens up, and I know that my x-intercepts are at 0 and at 2. So it looks like our upper function is the x-axis. So that's going to be the function y equals 0, and I'm going to have to subtract my lower function. The lower function is the y, which is minus x squared minus 2x. This is all with respect to x. So to evaluate this the definite integral, I'm going to first rewrite it. So negative x squared and minus a minus is a positive. So we have positive 2x minus x squared with respect to x. And the next step is to take the antiderivative. So the antiderivative of 2x would be x squared, and the antiderivative of negative x squared is negative x cubed over 3. And we have to evaluate from 0 to 2. So when we plug in our 2, x equals 2, we're going to get, we're going to get 2 squared is 4, 4 minus 2 cubed is 8, so we have 8 thirds, and we're going to subtract, we have to evaluate when x equals 0, so plug in 0. 0 squared is 0, minus 0 cubed is 0, and continue to simplify, and our final answer is 4. So 4 minus 8 thirds. 4 is also known as 12 thirds minus 8 thirds, and this is all minus 0. So my final answer should be 4 thirds This is area, so to write the answer completely, we have units squared. We're going to confirm this on the calculator. And let's see here. I'm going to enter the equation in the calculator. Y equals x squared minus 2x. We can graph it. Get a better window on this. Window of so we're trying to find this area, and to do that, we can go to math, integral from 0 to 2 of our upper function minus the lower function with respect to x. And we get our answer of 1.33. That's also known as 4/3. This is Mr. Martinez. Thank you for watching.